Thank you for joining us today for both on-site and online. My name is Achi Line from Computing and Informatics Department of Multimedia University. So without further delay, let's begin our program with the opening remark by Dr. Navaneethan, the chair of the IPv6 and 5G working group at APAN and senior lecturer at the Multimedia University. So,
okay, thank you. Thank you, Za. Right. Okay, good morning, everyone. Let me just 1 second. I need to put a background back to.
I said it was up.
Yeah, hold on. Let me check it. Let me download this. Sorry, guys.
Oh, wow.
Okay, done. Okay, can you guys see me? All right. First of all, thank you everyone for joining this morning. You know, we do not have many people here yet. I think it's a poolside. A lot of people doesn't know. We are very far from the poolside. From the main, we are the only room in pool house here. I think probably a lot of participants are down there. So next time the venue is not so suitable. Anyway, thank you very much for joining this morning. And this 68th APAN meeting. I think we've been having this meeting twice a year, biannually. So this time our working group, we were focusing on looking at IPv6 and as well as 5G together, how we can actually make sure that the internet is extended. As you know now, IPv4 already run out, and we are talking about IPv6 been there. Now, future is what we are talking about, IPv6 only. So this is what we are looking at. So this working group will gather all the minds who actually has on the same page, moving to single stack. So today we can see a few presentations coming in. The first one is talking about, from Vimal side, is talking about the research. So we are talking about IPv6 security, because since IPv6 is becoming the mainstream of the protocol, so there's a lot of security issues that need to address. So we are making sure that we bring in presentations that related to IPv6 security as well during this presentation, the meeting. Then again, this is the combination of IPv6, IoT, and 5G. It's together. It's the nice try later I will share with you. So with that in mind, we now focusing to make sure that working group, IPv6 5G working group, to focus on this area and hope to bring some people who are good speakers on this area. So without further ado, I will now call upon Vimal to actually, I think I'll hand it over to Za. Za?
Thank you so much. Now let's welcome the Mr. Vimalrich, a final year computer science student at MMU. He has a focused interest in IPv6 and network security, and he is proactively contributing toward the Malaysia's IPv6 adoption goal. He will present on improved fragmentation attack mitigation in IPv6 network. Vimal, you may start your presentation.
Thank you so much, Dr. Nava and Ms. Za. It's an honor to be here, everyone. Just 1 second. Let me share my presentation slides. Okay, are my slides visible? Can you guys see?
Yeah.
Yes, we can see that.
Okay,
Yeah.
sure. All right.
We can see it,
Right. So,
Thank you.
okay, thank you, Doctor. So as Dr. Nava has said, we have run out of IPv4 addresses. The 32-bit address space, we are completely running out, and it's time for us as a nation, not only as a nation, as all the countries in the world, have to transition to IPv6. The 128-bit address space has enough addresses for everyone. It is almost limitless when you calculate it. As such, Malaysia has plans to transition to IPv6 fully by the year 2030. But in my humble opinion research, we are not prepared. We don't have the necessary infrastructure, nor do organizations and internet service providers have enough resources to upgrade and adapt to IPv6. So my team and I came up with a concept for a host-based defense system. So I would like to introduce to you the improved fragmentation attack mitigation IPv6 networks, titled Dynamic Fragmentation. Sorry, 1 second. Dynamic Fragmentation Policy Mechanism. So the idea of DFPM is to block potential attacks and protect hosts in real time without any changes in network infrastructure or protocol. So this is the biggest key point here. No changes in network infrastructure or protocol, because the cost associated with upgrading and changing is extremely high, and that alone will delay us in adapting IPv6. So how do we address this? With the incoming technology that we have now, we have all sorts of generative AI, we have machine learning, we have deep learning. So not only can these things be used to create attacks, these things can be used to be taught to mitigate attacks. So we have combined machine learning and a host-based mechanism to help mitigate fragmentation attacks in IPv6 networks. And this is just a concept. This can be further pushed on to all forms of attacks. So the goal is improved security with minimal infrastructure or network protocol changes. And this research scope on this paper specifically that you can find at DIFCON focuses on 2 denial of service attack methods, namely the ICMPv6 flood, packet-to-big error flood, and the reassembly timeout attack. So I prepared a slide.
Sorry, Vimal. Can you remove, because there's highlighting the.
Sorry,
Okay.
Doctor?
Okay. Please carry on.
Okay. So I prepared a small simulation to help my audience understand how the attacks are carried out.
Let's have a view of how the packet-to-big array abuse. Let's have a
Sorry, can you hear the audio just now?
Yeah.
Oh, okay.
let's have a view of how the packet-to-big array abuse occurs. So as you can see, the attacker bombards the router with oversized packets by spoofing the IP address of the victim, and the router bombards the victim with packet-to-big errors, leading to a DOS. And as for the timeout error attack, as you can see, the attacker is sending incomplete fragment sets to the victim. So the attacker fills up the victim's fragment buffer, and now when a legitimate host tries to send legitimate traffic, it immediately gets dropped because the fragment buffer of the victim is full.
Right. I hope that was helpful in understanding just how a couple of attacks can result in a denial of service to a host. So, discussing related work in this field, I've prepared a literature review on 5 papers. So, all of these papers, they have come up with excellent solutions, but the only problem is that either the solutions were not streamlined, or they don't mitigate newer threats because they are focused on rule-based mitigation. Much like Snot and Surikata, only when the attack matches the criteria does it identify it as an attack. So this poses a threat because with generative AI, you can come up with all sorts of variations of attacks. And this does not help address zero-day attacks. Machine learning and deep learning helps us in addressing zero-day attacks by understanding the patterns of the attacks. So the attacks may be different, but the end result on how it affects the host is always the same. So this is how generative AI, deep learning, and machine learning come in. Some other solutions also require you to have hardware changes, infrastructure changes, or is limited to different environments. So what DFPM does, here is a sample topology that I've prepared to help viewers understand. So as you can see, we have an attacker and a victim. So DFPM is installed on the host victim. It's sort of like an antivirus system. You would go to the App Store or Google Chrome and you type in antivirus, you download and you click start. That's how DFPM is supposed to work. It's simple, it's straightforward. There's no complex setup. So there are three modules in DFPM. Firstly, the packet capture module, the traffic classification engine, which is the machine learning model, and the policy enforcement module. So let me explain step by step. So the first module is implemented at the host and captures all incoming traffic. So it just monitors in and listens in. So it takes a copy of that data and feeds it to the machine learning model. So once it's done that, it computes certain calculations to help identify attacks. So based on my research, these are some features or classifiers that help us in determining an attack. So I published a paper on this matter, and you can refer to the paper later on as to why these characteristics were chosen. So moving on to the traffic classification engine, it begins by taking the parsed data to identify whether traffic is malicious or benign. So for this specific model, I chose a decision tree because the research scope only focuses on 2 attacks. So there's no need for a heavy machine learning model. And its overhead and computational processes were really low. So this is why I chose a decision tree. So every time a feature matches a rule in the tree, a risk score increases the points by 2. So let me show you what the decision tree looks like. So the machine learning model uses this decision tree to understand and classify whether it's an attack or it's benign traffic. So moving on to the threat mitigation, as the model accepts the data and it classifies it as whether malicious or benign, it accumulates the risk score counter, and once it reaches 10 points, it blocks the traffic from the malicious source. So why a risk counter? Because when it comes to machine learning and AI, it's not perfect. There is always the risk of false positives. So that is why we implemented a risk counter to help ensure that the traffic is actually continuously malicious. So in doing so, that helps us reduce false positives. So once the malicious traffic is blocked, the host, can continue using your device safely. There is no disruption to your traffic. So here is a sample implementation of how it looks like. On the left is a topology visualization and an IPv6 fragmentation attack tool that we created to help people understand and learn how fragmentation attacks occur. So it's a live model that actually sends an attack, also helps you visualize it. And on the right is the DFPM network monitor. So much like an antivirus, it has start, stop, and revoke the block. So why I show logs is to help users understand why it's an attack, what is happening, whereas the final end version will be much more simplified. So what's on the right will be installed on the host. So it's just a matter of start and stop. So where is the novelty in this? As I discussed earlier, a lot of solutions work on rule-based detection methods, and they work for now. But with AI, we have to address the possibility of newer variation of attacks to help address zero-day attacks. And DFPM helps address implementation issues because all you need to do is download it and install it. There's no need for hardware changes or software upgrades. And a risk score counter system helps in reducing false positives, and it can be integrated on all hosts without changes in network protocols and minimal to no effect in network speed. So as for the results, we use 3 transmission rates, low, medium, and high of 5, 10, and 20 packets per second. And as for the measurement of the efficiency and accuracy of the machine learning model, we used precision, recall, and F1 score because these are the most common metrics used in machine learning for determining the efficiency. So in a closed environment, with very minimal data for training, DFPM demonstrated very high results. As you can see, we have an average precision of 0.96, average recall of 0.94, and average F1 score of 0.94. Even with minimal data, it seemed to be highly effective. So this proves that machine learning has a place in the future for network security. So a bit of discussion. There were some false positives in the normal category for the low traffic, low packet rate. This is because we did not have enough data for training, and it has not been tested in a live network environment. As for resource usage, in a closed environment, the CPU overhead was only 2% or less. Why this is not something that I'm emphasizing on is because we haven't tested it on live environments. This may vary in live network environments, so more research is needed. And due to time constraints, we were not able to benchmark it against existing tools like Snort and Suricata. But this will be done in a future paper that we're working on. And any single points of failure in the 3 modules will not result in your network traffic being disrupted. So there's no issue as to whether DFPM fails or not. There will be no disruption to your traffic. So in conclusion, a foundation in machine learning provides opportunities for extending its capabilities to identify all forms of attacks. So because we can train the machine learning model to identify all different forms of IPv6 attacks. So if you look at toolkits like THC, the Hacker's Choice toolkits for IPv6, there are about 100 different attacks, and we can train the model to identify as many as many as we can work on. And the FPM functions as an educational tool to teach people about IPv6 network security. Because I'm sure, I don't know about other countries, but in Malaysia, we're still teaching students on IPv4. But by 2030, we're already transitioning to IPv6. So there is a need for a change in syllabus and some tools to educate students on how IPv6 network security needs to be handled. So it's made to be run universally with no configuration changes. It helps us prepare for depletion of IPv4 addresses now. So a future paper, a future research will be focused on addressing more attack variants. It will be also focused on training, on creating a separate model to generate different attacks to train DFPM. And there will be live deployment testing and comparison with existing intrusion detection system tools. Hopefully, the system can be pushed to the government of Malaysia and governments all over the world to help countries in adapting to IPv6, because again, infrastructure changes require a lot of money, a lot of time, and it cannot be done just like that. It needs to be done carefully, it needs to be done slowly, and DFPM can be a tool to help people transition. And that is the end of my presentation. Thank you. I'm open to any questions if there are any.
Okay, thank you so much, Vimil, for your wonderful research topic. So, is there any question?
Is there any question from the members here? Anyone want to know? Actually, that is my student who is looking at IPv6. Because as I told you just now, IPv6 is a major issue that we are going to single stack. I think most of you know by 2030, Malaysia, especially I'm from Malaysia, right? Our government has decided that 2030, after that, there won't be any IPv4. And the US already started 2025, right? We do not want to keep on dual stack, because dual stack is costly. So while we are moving to IPv6, this is what the whole thing all about, what the whole event is happening. We see that there's still people are wanting to use IPv4. The major issues that we are dealing with this is not only the technology, it's the cost. With this, you have to support both IPv4 and IPv6. So that's why, I'm also sitting in the task force later, a member of task force, policy making in Malaysia. By 2030, we got total cutoff. If you are coming in from foreign to my country, and you still want IPv4, you are not given. That's the policy we want to make. That's the decision. Otherwise, IPv6 was there since 1999. And we will keep promoting, and people always want the easy way out. So still wanted to use IPv4 legacy. I mean, the other issues are there. Later we'll talk about it. The other issues are there. So security is one concern. Even though we moved to IPv6, IPv6 also got security issues, right? A lot of security issues as well. We know IPv4 is a lot of security issues. Now moving to IPv6 is more issues. Then especially what Vimal is covering, right? What Vimal is talking about. So this is a fragmentation attack. So he is part of my research, and we are actually expanding and looking at this as a product as well to educate people on IPv6. So we are now working to make this as a product to teach an IPv6 security issues. And I've checked around, there's not much product like this available. So we are looking at that. So actually Vimal won quite a number of awards for this product. He just got a top AI drive because he used AI to predict these attacks. It's not going to only predict one attack. We are going to talk about predicting other attacks as well. And IPv6, prediction of IPv6 attack, there's not sufficient tools because there's still ongoing issues are there. So this will be an educated tool, education, to tell people, like students want to know how is the attack taking place. That's why to teach them what is issue with thing. At the same time, you can apply into real world, right? So one of the things is he's talking about only detection, also mitigation, because the mitigation is the most important part. And he is proposing now host-based because on the network-based, centralized, you can't do much. So that's why we move. That's why you see whole firewall. So this product, what we have came out the idea, when there's attack detected, especially fragmentation attack, where you have empty sites, issues. Because in IPv6, the fragmentation is done not on the router. It is done on the host. So the router doesn't do it because we want fast, efficient, high-speed network. That's why in IPv6 routing, IPv6 routers only take care just routing, unless you're using jumbo payload. Then only the processing is done. So this product, inhaling that, but we have a fragmentation attack. So people can attack, packet too big attack. So they will be hazardous to the network. So we are trying to nip the problem from the host side itself. So this product, if they see the attack, actually basically he use the firewall rules to disable it, right? So this is an idea that we are now toying around. How do I do it in the real world? Because this is a test bed. That's why we had the opportunity to share this during this session to give you detailed information about what is the IPv6 security. And this tool, he only talked about two attacks, packet too big, and he was talking about fragmentation attack. Now we are looking into much more, because there wasn't much tools that's talking about IPv6. I know there is most of it IPv4, not IPv6, and these are new problems. As we are going to 2030 cut off IPv4, we need to address the problem now itself. So that's why this research is a very interesting research. Now we got quite a number of awards, and few more things is going in. So it'll be a better discussion. If any of you are interested in IPv6 security, my university, we are doing research mainly on IPv6. There are quite a number of undergrads are doing IPv6 security projects, and also masters. Za is my master student, and she also looking into, we have published quite a number of papers on IPv6 security, fragmentation, denial of service, and all this thing. So we can discuss more. I think I don't want to take much of my time. Now, I think Za, can we introduce the next?
Cesar, thank you so much. Now we are pleased to welcome the Mr. Conley, Director of the Network Innovation and Development Alliance, NIDA, and the Director of the Huawei French Representative Office, and the Director of Huawei VIB KAT Solution Sales Department. He will present about IPv6 plus open standard. Mr. Conley, you may start your presentation.
You want to share? Okay. So the problem is I didn't. Give me a second. Za, have you shared the slide to me? Hold on.
The background slide?
Yeah, you can slide because I didn't prepare the slides, you see. So Can you share it in the WhatsApp, whatever?
The background slide, sir. Which slide you want me to share?
No, I mean Kunli's, Likun's slide.
Oh,
Okay,
okay, wait.
hold on.
I'm sharing.
No, I'm just looking at this slide. You email the slide, isn't it? No. You emailed yesterday, isn't it?
Link.
Okay. Yeah. This one. Go. No, that's a document. That's a document.
Okay, I share with you WhatsApp, sir.
This one. This one. This one.
I shared WhatsApp.
Okay, in a minute. I use the WhatsApp. Okay, thanks. There's no pointers, nothing. The one, okay. Let me just do for you. Okay. That's the one. Okay, thank you. Is he sharing?
This one is Vimalrich.
Okay, hold on. I was wondering. Okay. All sorts. Okay, all yours.
Thank you, President Dr. Nava. Good morning, everyone. It's my great pleasure to be here to attend the IPv6 and 5G working group meeting. My name is Nikun. I come from Network Innovation and Development Alliance, NIDA, which is international standard organization, and focus on the network construction standards. And today my presentation will include two parts. The first is I will talk about the trend of the next generation network. And the second part, I will introduce a little bit on the NIDA Alliance and the IPv6 related standards released by NIDA and to be released by NIDA. So the first, let's have a look at what the network was like in the past and what will the network be look like in the future. So let's consider the 30 years since 1998 to the year 2030. The network has been changed a lot. We can divide them into three stages. The first stage is OIP stage. At this stage, the standardized traditional technologies, such as IPv6 and MPLS, were introduced by IETF and many by manufacturers. And it was driven by technological innovation. The second stage is all cloud stage. They are driven mainly by operators and OTTs, especially after OTTs joined the industry ecosystem. They separated the network from the data plane and the control plane in order to improve the efficiency of the network. So SDN and FV came to the reality. The third stage is all intelligence stage. And in the past, it was driven by the demand of industry enterprises, and the openness and the differentiation requested by the industry enterprises. They need a network support more protocols and to require the network to be more reliable. And especially after AI technology and the AI industry, which is the hottest topic now, and all the AI applications and the technologies are now requesting the network to be more flat, smart, and green and safe. So in last year, the China IPv6 expert committee, together with CAICT, they defined the 4 scenarios of next generation network. All these 4 scenarios combine the next generation network, and also they bring huge challenge to the next generation network. The first scenario is collecting to computing. We know that a huge amount of data centers are being built, and now the network, we need to consider not only in computing network, but also entry computing and intercomputing network. And in the past, 1,000 card cluster can meet the requirement, and then 10,000, now million card cluster can meet that requirement now. The second scenario is collecting to intelligence. And in the past, the collections of the network come from...
The slide is not moving.
Not moving?
Is the slide moving, guys?
No, not moving, sir. It's stuck in the first one.
Okay, sorry. Screen. Screen. No. Just wanted to show. PowerPoint. Screen. Okay. No, not existing. The entire screen cannot just yeah, how would I share the slide? PowerPoint is available. Is this power?
Yeah, but why we can just share the screen? I think last week.
No. It's not working. It's not moving.
We can do a share.
Since PowerPoint. Okay, I think okay.
Yes, that page.
Okay, can
Yeah,
move?
yeah, it's now working. Thank you.
Yes, you just click it. Okay.
Okay, sorry, didn't see the page, previous page. On this page, I introduced the 3 stages of the network evolution. And now we are coming to this. So the second scenario of a next generation network is collecting to intelligence. And in the past, the collections from the network can include human, family, enterprise, and cars. And now with AI participated, the AI plus human, AI plus family, and AI plus enterprise, and AI plus cars will generate more and more virtual digital will generate more and more collections, including virtual digital humans, embodied intelligent robots, etc. All these will make big pressure to the network to be more intelligent. And the third scenario is collecting the data. The data elements, huge amount of data elements, will require a trusted and high speed and a safe network. The first one is the collecting to communication satellites. In the past, the network focused on mainly on ground, and now and in the future, satellites and air, ground will be integrated together. So all these scenarios will lead to we need to have a high quality 10G campus network, high capacity LAN network, and a high efficiency data center network. So that's why the NIDA Alliance was founded. And the mission of NIDA Alliance is to define the evolution path and the network construction, and to drive the upgrade of the data communication industry. The network infrastructure will cover end-to-end network, including wide WAN network, LAN, and the data center network. So what's the positioning of NIDA? Let's have a look at the widest industry ecosystem. The 3GPP produce architecture, scenario, and define technical standards. ITU focus on vision and the requirement, and the GSMA focus on exhibition and promotion. And back to datacom industry. ITU focus on the scenarios and the requirements, and the WBBA focus on the promotion. And of course, IETF is producing technical standards. And the NIDA Alliance is focusing on the construction standards, so which is never touched by other international organizations before. Here is an organization structure of NIDA. We have 4 academicians, Hong Ke Zhang, He Chuan-Wu, and Yunjie Liu, and Shu Guangchui. And I know that Mr. Jianping Wu was previously the president of APAN, and all these are in the same level academicism. And we have a vice chair, Mr. Professor Suris from APAC IPv6 Council. And this year we established the expert committee. Mr. Dirk Kucher is the president of this committee, and he is a president of RITF, and also he is a professor of the Hong Kong University of Science and Technology, Guangzhou. And also this year we established the industry committee. They especially this year we will focus on the medical healthcare industry committee, and also education industry committee, and financial industry committee will be established. Now NIDA has 4 working groups. The first is network innovation working group, campus network working group, network intelligence working group, and the data center network working group. And the site security working group is on the way. Will be on site in next month, in August. So here we show the standards white papers NIDA released in last year. The first is an intelligent assessment report on next generation internet. Second, high quality 10G campus network technology development research report. The third one, technical requirements for intelligent OAM capacity of smart campus networks. The fourth one, technical requirement for network construction of intelligent computing data center. And we have a table for this year. This the current standards of next generation network. We can focusing on 3 target networks and the 3 key industries, including campus network, WAN network, data center network, and 3 industries include medical industry, education industry, financial industry. You can see 2 standards released this year, and 7 standards and the white papers ongoing, and the 3 white paper standards to be initiated this year. And all these standards, white papers were contributed by the NIDA members. Until now, the members of NIDA reaches 78 global members with carrier, device vendors, chip vendors, and academy and research institutes. And we have 32 members ongoing, and will in very soon the members will reach 110 in a short 1 year, because the NIDA was founded last year in June. And for the universities, the number will reach 27. So it's our honor to have already a telecom university MMU in our member list. So we warmly welcome to become a NIDA member and to work on the network, next generation network, and to build the network construction standards for network. And let's build an innovative future together. So I appreciate a lot for the invitation by APAN 60, IPv6, and the 5G working group. Thank you very much. Thank you.
Thank you for sharing your knowledge and experience with us, Mr. Lee Kon. Now we are pleased to welcome Mr. Ram Krishna Paria, Vice President of...
Can you wait?
Yes. Okay.
Look. You are now looking at net 5.5.
Yeah.
Okay, NIDA is really focused on fixed network. Is it on wireless?
NIDA is focused on the fixed network, especially on the telecom network. Many only. Yeah.
So basically, because today now we have issues like the MPLS, real issues. Okay, so alternatively you're proposing SRv6. Okay, so how do you see in this environment with SRv6 how it will help? Because are we in China? Are we all using SRv6? Are we related?
Okay. So you can see from this page, we have our key member from, for example, from CCSA and from CNIC. They are responsible for the IPv6 management in China, and NIDA Alliance is a platform to invite and welcome all the members to do together, to do things for the IPv6 deployment and the promotion. Now, I do believe with your participation and together in this platform, we can together do research and to make standards for the industry.
So people can join NIDA, become member,
Yeah,
and they can contribute.
exactly. Exactly.
So now, is anybody already start looking at which working group is looking at? Okay, there's a question. Okay, NIDA,
Ah, okay.
can you answer the question?
Sorry, the
Okay.
question.
No, they wanted the video. So at first, activity is 5G. So how we can work together? Anyway, we're signing the MOU.
Yeah.
Okay. So then they can they access to your that's the what the benefit joining NIDA?
Okay, to join NIDA, the first, I think for the research and the institutes and the universities, mainly they focus on because we welcome both of them. One is the research. The second is for example, the network construction. For example, for every university and institutes, they have their own department to do the real construction. So we both really welcome these two parts from the university, for example. And I think in near future, currently we focus more on the, for example, not the research part. That way we focus on the construction standards with the existing protocols, existing technologies. But I think in near future, we will consider, the finance will consider to how to unitize the research the teams from universities, etc. Yeah.
Thank you so much.
Thank you.
Thank you so much.
Thank you.
Okay. So now let's welcome the Mr. Ram Krishna Bariya, Vice President of Technology at Subisu Limited, Nepal. He is a network and cybersecurity expert with over 20 years of experience, and he is a key figure in IPv6 and policy development in Nepal. He will present on IPv6 development in Nepal. Mr. Ram Krishna. Thank you.
Very good morning. Are you able? Hello.
Yes, sir. Can hear.
Let me. Okay, let me share my screen.
Sir.
Okay. Very good morning, everyone. Thank you, Dr. Nawa, for this opportunity for me to share my experience in the APAN 60 program. Today, I'm going to discuss or going to share my experience, especially in IPv6 deployment and development in the context of Nepal, and depth analysis of the digital ecosystem and strategic forums directions. Okay. Regarding myself, yeah, my name is Ramkrishna Pariyar, working as a Subisu Subisu Limited is one of the ISP and one of the leading ISP and NSP in Nepal, right? Apart from that, I also involved in the different local and international forum as well. I'm representing from NPNOC as a founding vice president as well, right? Today I'm going to discuss about this, like basically 4 agenda: Nepal's digital landscape, ISP and NSP telecom statistics, right? IPv6 deployments, a journey, and futures development plan. Okay. Nepal digital landscape. Okay. Nepal has a diverse demographic with growing urbanizations, is like a high mobile penetration sites, connectivity, and internet users have steadily increasing over the year, right? The focus on digital educations and access to information technology is key in promoting connectivity nationwide. You know that Nepal is a small country situated between India and the China, right? Is one of the is like a very beautiful country as well, right? This is like a cross border point of Nepal's. As of now, we can connect or we can carry the internet from 7 different locations, 5 from southern part, that is from India, and 2 from northern part is from China. From the southern part, we have the major 5 exit point. So one of them is like from Viratnagar. We connect India from Viratnagar. We also connect PUI from Dalkewar, right? We also connect from Birigans, this is Roxol, right? We also connect from Bhairava, Sunauli, and we also connect from Mahendranagar, right? The more active part is from 3, Bhairava, Birigans, and the Biratnagar. Three are the measures like connecting from India to Nepal, and we also connected from 2 exit point from northern side of China. One is from Rasuagadi and another is from Tatopani, right? If you see just like IPv6 global snapshots, thank you for the APNIC. I got this information from APNIC, right? And the global preference IPv6 is like approximately it's like a 38%. The Asia is like 43.14%. North America is approximately like a 53%. South America is 36%. Europe 30%. Africa 2.4%. Oceania 35.8% is the IPv6 global snapshots. If you just talk about the Asia sub-region, majorly like a 3 sub-region, we're just discussing 3 major sub-regions, right? 3 sub-regions like Southern Asia is almost like 57.7%, where India, Sri Lanka, Nepal, Bhutan, Pakistan, Bangladesh, Afghanistan, and Maldives. And Eastern Asia is almost 45.2%, and the Southeast Asia 31.2%. Right? Out of those, you can see some data from Nepal as well. So Nepal is almost like a third positions in terms of IPv6 deployment in the APAC, in the South Asian sub-regions. It's almost like a in year 2020 is 28.60%. In 2022, it was 32.71%. In 2023, it was 36.44%. From 2024, it's almost like 59.43, 60%, and now it's like a 49.70%. That means it shows like Nepal also growing, especially in the in terms of IPv6, right? This is the statistics of IPv6 preference, right? If you just say like about the IPv6 deployment journey in Nepal, it started from 2011. Before that also, we also use IPv6 as a tunnel broker with Hurricane Electric. From 2011, we start dual stack IPv6 from Sanok 11 from Pokhara, one of the beautiful city of Nepal, right? For that, I think I need to thanks NTT as well. NTT also give us dual stack IPv6 during the Sanok with Subisu, right? Subisu is the first ISP who deploy IPv6 in Nepal, right? Before 2011 as well, we also use IPv6 in ours like local IX is NPIX. Few members already deploy IPv6 during that time, right? And from 2011, my company Subisu started IPv6 in our network. And from 2020, we also started from IPv6 more focus. We conduct so many workshop, seminar, especially for the operators in Nepal, right? With the help of local communities like NPNOG, Nepal Research and Education Network, NRN, and the others local community, APNIC, SANOG, and the Apricot, right? As of 2025, like the government also like a more the government is Nepal Telecommunication Authority also like give a more interest on IPv6. They also like prepare to make IPv6 migrations mandatory in all the operators. They are also in the good positions to deploy IPv6 in Nepal. Okay, this is the like statistics of IPv6 journey in Nepal. Is almost like a 50% in more than 50% IPv6 in 2024. In 2025 is almost like a 50% IPv6, right? ISP and telecommunication industry statistics is, you know, that the population of Nepal is like 29.2 millions with 47.63% fixed broadband penetrations is FTTH broadband penetrations, 90.36% mobile broadband, representing 3.1 million household, and nationwide around 50% IPv6 penetrations. Out of that, like as per the Nepal Telecommunications Authority data, right, we have 107 registered ISP, 26 NSP, network service providers, and 2 is operators, telcos, Nepal Telecom and Ncell, right? ISP telecoms industry statistics, like what are we looking at? Is IPv6 really going backward? That is like it's a controversy, yes and no. You can see the data from the like 2024 and 2025. 2024, the data is increasing, right? In 2025, I think like in the globally V6 adoptions is also decreasing. That means like, what are these others contributors to for that, right? In the context of Nepal, like out of 107 ISP, internet service provider ASNs, 7 operators are over 50% IPv6 preferred. 6 have a good quantity of eyeballs as well. 12 operators is between 10 to 50%, and 76 operator is less than 1%. That's why like Nepal Telecommunications Authority also like publish papers and the consultation papers and saying like they are preparing to make IPv6 migrations mandatory for operators as well. They're on the coming in the pictures as well, right? Observation during my deployment, that means like that was in the from 2011 to 2020. In that during that journeys, we have faced so many issues with the vendors and some technical issues while deploying the IPv6. You know that in the 2011 when we use IPv6 in our network, right, in the dual stack, at that time we forgot to deploy proper quality record, proper proper deployment. V6 is our like infrastructure network as well as our DMZ network as well, right? And that during that time we have not like think about the like filtering these things, right? And suddenly like when you deploy IPv4 and IPv6, IPv6 gives high preference. And then when the query record is not properly configured, and the traffic will be black hole, right? So that's like the customers is like complaining with the with IPv6 issue. Then we rigorously work and identify the solution, and we properly deploy. And as of now, it is good. During that time, I have some observation. One of that observation is excessive DHCP solicited message. CPE send multiple DHCP solicited message instead of single optimize one. Network overload. These behaviors overwhelm the network during user session, so that my BNG, CPU utilizations, and the memory utilization is almost like 100%. So I need to reboot the BNG, and the impact of rebooting the BNG is really, really bad, and the other customer also get affected. DHCP server overflow. The flow of requests cause overflow at the DHCP server. Service degradations resulting in delay provisioning and degraded service performance. That was the observations which I found during my deployment in the years 2011 and 2020. Right. The key contributing factors: lack of rate limit. CPA had no rate limit mechanism for initial DHCP solicited behavior. Worsening traffic flooding. Dual stack configuration challenges. Requires joint IPv4 and IPv6 bandwidth management, which was not initially supported. Right? The missing dynamic policier, especially in the BNG and the AAA. The systems lack a dynamic policiers to enforce per user bandwidth limit retrieved from the radius servers. Okay. The basically I'm just categorizing these observations: traffic filtering issue, IPv6 and multicast challenges which I faced during my deployment, visibility of IoT device, ONT devices, and some security gaps as well. Right. The solution is we need a more coordinations with the vendors. The team heavily rely on coordinations with vendors to resolve CP and access network related issues. Multicast configurations variability. Multicast functionality has to be manually enabled on some vendors OLT, and in contrast, other vendors OLT have had a multicast enabled by default, requiring to manual intervention. That means using a multiple vendor is also challenging to deploy the new technology, right? We also face the same in the different vendors which we use, and some of the vendors the default multicast is configured, and some of the vendors we need to configure manually, and some challenges also face. And that's why we need a very close relations with the operators and the vendors. Without vendor support, it is very difficult to fully deploy the basics. Challenges and strategic solutions. The challenges and strategic solutions: the legacy infrastructure require costly upgraded for IPv6 compatibility, limited awareness and technical expertise among network administrators, dual stack complexity increase operations overhead and cost. Yes, definitely when you use the dual stack, it consumes the double bandwidth, it consumes the double cost, IPv4 as well as the IPv6. The strategic solutions: implementing comprehensive training and certifications program nationwide from the local community as well as from the APAN also start, and APAC basics also will start basics training. Government policy mandate IPv6 adoptions in public networks, industry collaborations and acknowledge sharing through technical forum, right? The challenges and strategic solutions: in users acceptance, residential and mobile business and enterprise. As of now, especially in the retail residentials and mobiles operators, right? We are almost a 60% IPv6 deploy. Now the concern is for the enterprise customers. The enterprise customers, we need to work out with them. There is no any business case for them to upgrade IPv6. They use the different applications for their own purpose. We need to convince them, and we need to work out with them or train them to deploy IPv6. Networks not ready. Older equipment, yeah, some of the operators, we need to replace older equipment. software billing, additional license costs, especially for mobile operators. The people, in terms of people, staff are not adequately trained. Still, training is required, right? The current terrain industry training rarely address IPv6. Previously, almost every Sanok, Apricot, we also did IPv6 deployment workshop as well. Even as of now, we also need to encourage to schedule such type of training in coming workshop as well. The misconception on use, lack of ability to adequately address plan, management not willing make changes, and these are the some challenges. And why deploy IPv6? What is the advantage for IPv6? IPv6 makes network engineer life easy, and the management, in the prospect of the management as well, is very easy to manage the data and is managed. That's why we need to deploy the IPv6. One of the part is the cost. IPv4 cost is too expensive. We can see so many like IPv4 lease company, and the IPv4 address space for the per IP it costs around USD $40 to $50, right? For the /24 we need to pay 12,800. And another is hardware cost is too expensive. The CGNAT is not free. We need to invest a huge amount of money for the CGNAT, and the NAT is not a permanent solution, right? It's blocked into invisibility as well. That's why once we deploy IPv6, the CGNAT cost also reduce, IPv4 cost also reduce. The world is changing, 3 times increase next 5 years. Hyperscalers are catching up. CDN providers are ready for your IPv6 packet, right? IPv6 typed over the 50% mark in the Asia this year as well, right? That's why the IPv6 we need to migrate to IPv6. Okay, the future roadmap, development roadmap. Yes, obviously we need to again follow awareness campaign, comprehensive IPv6 awareness and training program for ISP and enterprise customers as well. The policy development, government mandate for IPv6 adoptions in public sectors network. Industry collaborations, yes, definitely enhance partnership between ISP, training organizations, government, and academia, right? And the fourth one, implementations, accelerated IPv6 deployment across all network operators nationwide, monitoring and optimizations. Yes, continuous monitoring and performance optimizations of IPv6 network. These are the some futures development roadmap. We need to conducting training program, technical training program, building IPv6 expertise across Nepal's networking community, APAC-V6 certifications program with certified practitioners, NPNOC technical workshop and hands-on training sessions, SANOC, APAN and regional conference participants for knowledge sharing, strategic partnership with international organizations advancing IPv6 adoptions in Nepal, the global partnership like APAC-V6 collaborations for training and technical support resources, APNIC, Apricot, SANOC, APAN, NPNOC's community engagement and regional knowledge exchange program, APAC-V6 Council's partnership for research and development. Yes. And the policy initiatives, government and industry initiatives promoting IPv6 deployment and policy advancements. Nepal Telecommunication Authority regulated frameworks developed for IPv6 implementation standards, and they're also prepared to make IPv6 migrations mandatory in all operators in Nepal, right? ISP collaborations program for coordinated IPv6 deployment strategies, public sector's mandate for IPv6 adoptions in government networks. Okay. Thank you very much for this opportunity. Once again, if you have any questions, I'm pretty much happy to answer it.
Yeah. Any question to? Thank you, Ram. Any question to Ram? Anyone here have question? Okay, Ram. Just what if they? I want to ask. How
Yeah,
about
please.
currently, what is your direction for IPv6 only in Nepal?
Can you please repeat one question, sir?
No. What is your strategy for IPv6 only for Nepal? Is there a
Yeah.
government laid out strategy
Yeah.
now?
Yeah, thank you for this the questions. Actually, like in Nepal for deploying the IPv6, like we have a very strong local community over here. It's like NPNOC, NPIX, and ARIA Nepal Research and Education Network as well. We conduct so many workshop and seminar to all operators and the some of the enterprise customer as well, right? Now, the regulatory body, Nepal Telecommunication Authority, also like give an interest for us to like adopt or deploy IPv6 aggressively in Nepal as well, right? So that like we're also working with the government for policymakers to like mandate IPv6, especially in the operators, telcos, ISP, NSP, and the enterprise customer as well, right? The main part is awareness is major concerns. Still, we are working to aware through the workshop and conference to the enterprise and the enterprise and vendor itself as well, because like the new operators are ready for IPv6, but the older operator still is like a delay to deploy IPv6. The main reason is like they need to upgrade their devices, right? And some of these like the CP device is not fully support IPv6. I think we need to also working on to like IPv6 certifications for the vendors as well.
Okay, thank you, Ram. Thank you very much. Hope to
Thank
see you
you.
next time, next APAN in Bangladesh. Maybe you can join us in Bangladesh. Okay, thank you once again.
Thank you,
Okay.
Dr. Nava, for this opportunity.
Thank you. You take care. Bye. Bye. Anissa is already joined?
Yes, already joined. Okay, thank you very much for the informative knowledge, Mr. Ram. Once again, okay. Our next speaker is Mrs. Anisha Safrita, Operational Service Officer at the Ministry of Communication and Digital Affairs, Republic of Indonesia. She plays a key role in advancing IPv6 and 5G deployment and in modernizing telecom policy in Indonesia. She will present on Indonesia IPv6 deployment and development. Ms. Anisha, you may start your presentation. Where? Okay, he is here. We are not able to hear.
Wait for the moment, okay?
Okay.
Anisha, can you unmute your mic? Anisha, can you unmute your mic? Anisha, can you hear us?
Yeah, okay. My presentation can be viewed.
Yeah. Can
Okay.
you please present? Okay. Go
Okay,
on.
okay. Wait a moment. Okay, good morning, everyone. I'm Anissa Safrida from Communication and Digital Affairs of Indonesia. And this morning, I want to share about progress from Indonesia for implementation IPv6 POV on policy and regulatory framework. Okay. In Indonesia, is rapidly catching up in IPv6 adoption by aggressively strengthening its policy and regulation. Since 2022, when IPv6 penetration was at 12%, the country has since steady growth, reaching 16.57% today. This shows Indonesia's strong commitment to accelerate the transition towards a more advanced and efficient internet infrastructure. So the data I get today in Indonesia, IPv6 capability 16.57%. Okay, but in Southeast Asia, Indonesia still 6 and more still the implementation of IPv6. Okay. Regulatory landscape in Indonesia. We are, as a Ministry of Communication and Digital Affairs, is a leader for regulator coordinating national IPv6 adoption. And we have established a cross-sector IPv6 task force, and we regulation in Indonesia for IPv6 and roadmap is Ministerial Decree number 13, years 2014. And the roadmap serves a strategic guide for fast IPv6 implementation across Indonesia, outlining case stage for systematic adoption for IPv6. And past initiative laying the foundation for IPv6, we are we realized a building awareness and trust was crucial. So we brought everyone together, government official, industry players, and the public through national event like the National IPv6 Summit and World IPv6 Day. This gathering help us share knowledge and align everyone's vision for a better internet. But we know awareness alone wasn't enough. So we reached out directly communities and end user, explaining in simple term how IPv6 will make their daily digital activities smoother and more secure. Lastly, we stood alongside our telecommunication operator. We didn't just set target, we gave them hands-on technical support and clear guidance to ensure transition of IPv6 could happen efficiently and with confidence. So, future vision for Indonesia. Looking ahead, Indonesia has set a clear an ambitious vision for IP version 6 adoption, referring to National Strategic Digital Economy 2030 white paper. Our target is reach 46.8% for IP version 6 penetration in by 2030. Achieving this goal will require well-coordinated strategy, strong policy support, and collaboration among government, industry players, and the community. Through this commitment, Indonesia aims to ensure the digital infrastructure remains future already and globally competitive. And for future plan for IP version 6 adoption, point 1, we streamline regulation and policy. We make revision of our regulation number 13 and in years 2014 and about IP version 6 roadmap implementation with stronger timelines and clear staging for each stakeholder. And we revision our ministerial regulation number 32 on year 2015 about internet protocol number management. And we issue a circular letter for platform, content, application, and data centers to accelerate IP version 6 adoption. And for Ministry of Industry to mandate IoT and EDC device to support IP version 6. And point 2, on technical and industry support, providing implementation assistance to telecom providers, and encourage device manufacturer to enable auto configuration, establishing an IP version 6 certification testbed with IDTH as a national test lab. So in Indonesia, we have IDTH lab for all test bed. So we designated IDTH as a national IP version 6 test lab. And point 3, awareness capacity building, conducting ongoing community outreach and public awareness campaigns, increase capacity building through workshop and training for all sectors, and evaluate all stakeholder progress annually by Ministry of Communication and Digital. Point 3, for application, we can focus encourage pushing application, website, and content providers to fully adopt and integrate IP version 6 into their service and platform. Okay, for accelerate IP version 6, we collaboration with multi-stakeholder. The first, APG, Indonesian Internet Service Provider Association. We and point 1, driving awareness and capacity building on APG has proactive promote IP version 6 through nationwide awareness program, technical workshop, and collaboration with university in Indonesia. by provide training in city like Balikpapan, Yogyakarta, and Bandung. APG help build the technical skill to address the humans, one of the main challenge in IPv6 deployment. And point two, with APG, we efficient IP resource management through ITNIC and APG, which acts as Indonesian National Internet Registry under APNIC. APG ensure transparent allocation of IPv6 address to ISP and organization nationwide. This guarantees sufficient address resource to support grow IPv6 in Indonesia. And APG has also launched honeypot project at multiple Indonesia Internet Exchange location to strengthen cybersecurity and develop threat intelligence. This project initiative complement IPv6 built-in security feature like IP security, ensuring a safer internet environment. And point two, we collaboration with APNIC, the Asia Pacific Network Information Center. APNIC allocate IPv4, IPv6, and autonomous system numbers for the Asia Pacific region, including Indonesia, based on transparent community policy and actual needs. And APNIC regularly publish IPv6 adoption static at global, regional, and national level. This data help stakeholder in Indonesia monitor progress and make evidence-based policy decision. And APNIC support local project, including collaboration with universities, such as University Islam Indonesia in Yogyakarta. This multidimensional support ensure Indonesia IPv6 strategy align with global best practice and benefit from international expertise. So with collaboration with multi-stakeholder, together APG and APNIC demonstrate how collaboration between local association, global internet registry, operator, academia, and government is key to building resilient and future ready IPv6 ecosystem in Indonesia. Implementation IPv6 in Indonesia. Indonesia commitment IPv6 is not just word on paper, is becoming real on the ground through concentrate example across sectors. In the government, in South Tangerang City is one of the pioneer at the local level. In June 2024, Tangsel upgrade its all core network and e-government service to dual stack. They didn't stop at infrastructure, but they test smart street light and air quality sensor that run natively of IPv6. As a result, up to 80% of their government application traffic is already IPv6, earning them national recognition as the best IPv6 government implementer of 2024. In education, University Islam Indonesia has led by example since 2018. the campus network with more than 30 million users, plus mainly on IP version 6, handling cover 60% of their traffic, all support IP version 6. And for telecommunication sector, we have a BizNet, like ISP have fully deployed dual stack for the backbone and customer, both at home and in business. They pair directly with global and local IP version 6 partner, so their customer gets seamless access. They also help customer configure router and promote IP version 6 ready device. Major mobile operators are testing IP version 6 for 5G too. Sorry. Okay, challenge and next step in Indonesia for implementation IP version 6 in challenge. First, our geography is unique. More than 17 billion island mean network upgrades can reach everyone at the same pace. Second, many older devices in use today simply don't support IP version 6 natively, which slow adoption at user level. And the third point is investment requirement. Rolling out IP version 6 requires heavy investment in infrastructure and human resource, which is not easy for every operator. To tackle this, Indonesia is taking considerate next steps. We will integrate IP version 6 into national digital government policy and procurement standard. All new renew ISP license must meet IP version 6 readiness requirement. A new circular letter will we require for platform, application, content provider, and data center to adopt IP version 6. We are also investing in robust testing. Our IP version 6 certification testbed will be recognized by the Global IP version 6 Forum, and in the Indonesia Digital Test House will certify device and system, including owned by digital service providers. So with this step, we are confident Indonesia can overcome these barriers and build a strong future-proof IP version 6 ecosystem. Okay, Indonesia is steadily and systematically accelerating its IP version 6 adoption journey. This progress is only possible through continuous collaboration among government, industry, academia, and regional partners. We invite all stakeholders to work with us, whether through technical cooperation, joint capacity building, or policy harmonization across the region to ensure that no country is left behind in this transition. Thank you for kind attention. We look forward to your insight and idea during the Q&A session. Thank you very much.
Okay, thank you, Anissa.